Καλημέρα σε όλους. Ελπίζω να ακούγομαι καλά. Καλημέρα. So I'm gonna continue this presentation in English, since it looks like this year we have many speakers that are international, and also we have many attendees that are from all over the world as well. And also this presentation is recorded and will be uploaded online as well. So let's get started. My name is Bill, and you can find me whenever you want on this following handle, on Twitter, Facebook, anywhere, and on .netweekly.com and fullstackweekly.com. So we'd like to thank our sponsors for the event today, and let's get started. So this event is getting started with progressive web apps, and the goal of this presentation is to introduce progressive web apps. We will answer the question, what is a progressive web app? And we will transform a simple web page into a progressive web app to figure out what are progressive web apps. So everything started in 2010, 2011, somewhere over there, where native apps were making such a big impact in the world. And I really remember this phrase from Mark Zuckerberg, where he mentioned that the biggest mistake the company made back in the day was betting over HTML5 over native. So Facebook really invested in HTML5 back in the day, and they quickly changed their strategy into using native apps instead of only web apps as well. Also, another interesting statistic is that in 2014, more users were accessing the web on their mobile devices than on the desktop devices. And also, mostly users access the web or internet services through native apps instead of using the mobile web. And most of the time that they spend is on the three most popular apps that they have on their phone. So there was a conversation back then of how can the web become more relevant, and what improvements should there be made so that web apps could have a better experience for the user and become more capable as well. Because the biggest advantage that web apps have is that they have an amazing reach, but they weren't as capable back then. So when using a web app, we have less control, less hardware features, and mostly we use JavaScript. So how can we change that, and how can we improve the experience of our web apps so they can become more capable, have a better user experience, and be stronger, and not only on the mobile devices but on the desktop devices as well. So Google has created this website called Showcase, if you want to get excited, where if we visit this website, they have use cases about progressive web apps and how these technologies have benefited companies all around the world, and you can check out all the user stories over here and how it benefited them on a business perspective. Okay, so what is a progressive web app? Concerning the user experience, a web app is considered a progressive web app when it loads instantly, when it's served over HTTPS, it emulates apps, so it emulates their behavior, it has an offline first approach, it is crawlable, discoverable, and installable on the device as well. So this is concerning the experience side. Now on the tech side, for a web app to be considered a progressive web app, the minimum requirements is for it to have a service worker and a web manifest. So if we can take something from this presentation, and if we deconstruct progressive web apps as we hear about them today, the bare minimum thing that a progressive web app should have is a service worker and a web manifest, and also use strategies like the app shell to cache the client data locally, and also leverage the client-side storage as well. Okay, so we're going to go over the tech requirements for a progressive web app, which are basically these four, and the presentation now is split into 4 parts. Each part is going to dive into one of these tech stacks. So first of all, a good strategy while creating your progressive web app is to use the app shell technique. Let's take, for example, Twitter. If we have our mobile device, Twitter usually has an icon on our device's dashboard, and we can click on that icon or tap on it, and first it will load the splash screen. Then it will load the app shell, which is the static assets of the app, and this is a native app. And then it will load the dynamic data. So we can consider the app shell the stuff on the left, which is all of the icons and JavaScript and styles and stuff that we can store locally and can load instantly whenever the user uses our app. And on the right is all the dynamic data that comes from usually a web service. So we will create a car deals website, a website called Car Deals, and that website will have an icon on the home screen. And when you tap on the icon, it will show a splash screen. It will load the app shell, and after it loads the app shell, it will load the dynamic data as well. Okay, so let's see an example of this app shell technique. So I've loaded a simple web page over here. This has an index.html, which is the HTML part of my app. And this consists of a very simple header, which loads some styles. It loads a JavaScript module and has 2 parts. The main area, where it loads the dynamic data of our site, has a container for my dynamic data, has a template, and loads the app.js module. So in the app.js module, we're loading our cars. And if I go to my car service module, this loads the cars from an endpoint. This is a JavaScript object and a JSON object, and then we append the cars on our browser. So the cars come from a web service, and then we have a template that loops through the cars, and for each one of them, it appends them on our browser. So let's check out what we're going to see. If I refresh my page, we have this very simple website. So there's nothing progressive over here right now. It's just a simple web page where we make a request, and this request returns 3 cars, and then we append these 3 cars on our browser. And if we click on a card, it does another request, some HTML, and appends that on our browser as well. But the interesting thing about our website is that it's into two areas, and the static part is completely different than the dynamic part. So all of our assets over here, we can store them locally. we can store them on a CDN, there's no state, and data is loaded afterwards. So that is the technique of separating the static and the dynamic part of your website, just like a native app. Whenever you load Twitter, Facebook, whenever you download an app, you download all the static content, and then it gracefully starts loading all the dynamic content. So the second part of a progressive web app is leveraging the client-side storage APIs that we have in our disposal. So let us check them out. First of all, everybody knows cookies. Cookies were probably the first method to add state in our apps, and it is a way to store data locally, but it's only 4 kilobytes, and it depends on each one on every request. Then we have the HTML5 Web Storage, where the size limit is 2.5 to 5 megabytes. Then we have WebSQL, which was used in the past, but now it's deprecated. And then we have IndexedDB. So these are the 4 APIs that we have at our disposal whenever we want to store data locally. And we have to decide which one of these we want to use and which one we want to leverage. Now, IndexedDB looks like the most promising one because we can store JavaScript objects. It is asynchronous. We can store large data sets, and we can store a lot of data. So devices usually are very generous when you're using IndexedDB. But the negative is that it has a steep learning curve and it's complicated. So from the storage options that we have to store data, in general, people choose IndexedDB, and they use HTML5 as a backfill. So let's check out our app. This was this very simple app that we saw before, and I'm going to update this. So I'm going to update this so we can use a local storage option. So I'm going to check out PWA client storage. Okay. So what did we do over here? Basically, now I'm loading a library called local forage, and remember previously we just were loading our cars. Now whenever we load our cars, we will load them with a fetch promise, and we will load our cars with the fetch method. And whenever we receive the cars back, we will run this add cars method. So this add cars basically will add the cars in our local storage using IndexedDB. So now we're not only loading our cars, but we're also storing them locally as well. And also, instead of, we don't only store the JSON data, but we also run this pre-cache details page where we're using the cache API, which is another API that we'll see later on, to store assets locally as well. So let me refresh my page. Okay, so previously, as you saw, we were just loading the data using an HTTP request. Now we're loading the data, and we're also storing the data locally as well using IndexedDB. So we got our 3 cars over here, and we also stored them in our IndexedDB database. And also, we're using the cache API to store our assets as well. And the assets are these 3 pages over here. So we leverage APIs right now to go one step further. And we're not only loading the data from our app, but we're starting to store data locally. and that's either JSON data, JSON objects, or assets as well. And these can be, in our case, these are stored as strings. These could be images, HTML pages, you name it. Okay, so part 2 is done. We have our app. We have our app loading. It's using the app shell technique to separate the static and the dynamic part, and we're also storing our data locally as well. So how can we leverage these techniques to make our sites really offline first and improve the speed and the performance of our apps as well? And also eventually have the awesome label of a progressive web app. The cornerstone of a web app is the service worker. So this is probably the most important part of a progressive web app, which is the service worker that will connect all the pieces together. So the service worker is a script that you can install it on your browser, and it can actually run even when your website is closed. So it's a script that you install on your browser, and it's extremely strong as it can intercept network requests for the domain that installed it as well. It runs on its own thread, and also it has some functional events such as push and sync. So your typical HTTP request would be to either your browser, whenever you do a request, it either searches for that asset locally, and if it doesn't find it, it goes to the internet to retrieve the data. Now with the service worker, we can install a script on your browser that will intercept all of the requests, and we can actually add our own logic to retrieve and store data locally. It also has events such as the push event that we can trigger from our own service whenever we want on the client. And also the sync event that triggers every time the user goes online or offline. So it's a script that doesn't have a DOM access. It's not a page. It has its own context. It gets installed through HTTPS. It runs without a page, and it's event driven. Now, when we install our service worker, it goes through all these different steps. First, we trigger an install request. It gets installed, activated, and then redundant. So whenever we introduce a service worker through our web page, first it's in the installed state and then in the activated state. Okay, so let us check this out. So I have my app over here, and I will check out the service worker. Okay, so here we are. Now in my index.html, I'm loading the app.js module, and this module is loading the SW register module that does a lot of stuff over here for logging the service worker. Let us not get consumed by that, but it's running this for starters, which is basically saying register this script. And this script over here is the service worker. So this script will get installed in your browser. And as we saw, it has different events. So when we trigger this file over here, register sw.js, this triggers the install event, and the install event, we can do anything that we want. In our case over here, I'm going to get all of the static assets that our web page has. So I'm going to loop through all of the different files that I have, and I'm going to store them in our cache API. So remember previously that we stored all the pages. Now I'm going to store all of these assets as well. And later on, we can load these assets as soon as possible. So let's go to our web page. I will refresh. And if I go to my service worker section, you can see now that this sw.js script that I showed you was activated, installed, and is running in our browser. So if I go to my cache storage again, you can see that this didn't only store the car pages that we saw previously, but it also stored all of the static assets of my web page. And also it dynamically stored images as well. So if the user for any reason now goes offline, and if I refresh my page, we can see that it did load the data as well. So although the requests failed, the service worker worked as a proxy to load the data, the assets, and the dynamic data as well, so that the user has actually access to our website's data. And now, if we didn't have the service worker, they would see the oops offline page, or like the dinosaur that Chrome has, or all that stuff. But now, with the service worker, we installed a proxy that stored all the static assets of our website and also stored dynamic data as well. And whenever the user tried to access the site offline, we did have those resources available and we could retrieve them. And if we go online again, we can continue to use our web app. And if we go offline, we can continue to use our web app as well. So you can see that this doesn't only improve the experience that people have, but also if I refresh my page, all of the static assets came from my service worker and came from the cache API. So they didn't even go through the network, and we managed to serve all the data through the service worker. So let's go back to the service worker to see how this is possible. Every time we make a request, this fetch event is triggered. And depending on the strategies that we have for our different assets, we can conduct different events. So for example, I have 3 strategies over here for my files, for the assets and for my endpoints. The first strategy is the network first strategy. So whenever a user requests something from my latest path, where my latest path is just the latest deals, over here, we're using the network only strategy that basically it works as if we didn't have a service worker. It only uses the network. Then we have the network first strategy. So the network first strategy will first try to retrieve the data from the network, and if it's not available, it will retrieve the data from the cache. And then we have the cache first strategy that is used for all of our static assets, which is basically all of the static assets that my website has. And whenever somebody tries to retrieve one of these assets, we first try to retrieve the data from the cache, and if it's not available, we use the network as well. So we're using these 3 network strategies, these 3 caching strategies, and we have full control of how will we retrieve the data, and how will we serve the data to a user, and when to call what. So we can go over these strategies again. So remember the fetch method. The fetch method is available when the service worker is installed, and any request that we make from our website goes through this fetch event. And we have the network-only strategy that is used for all of our latest car deals, and it first tries to, it only uses the network as the source of our data. Then we have the network first, then offline. We're using this for our images in our current use case. And it first tries to retrieve the data from the network, and if it's not available, from the cache. And then we have the offline first strategy that first tries to retrieve the data from the cache, our local cache, the cache API, and then from the network. And lastly, we could have other strategies like offline only strategy that we don't have over here, which could store the battery life or something like that. Okay, so as a recap, we used this .register event method to install this script on our browser, and then whenever we made a request, the fetch event would trigger. So our service worker works as a proxy between our web app and the network, and we could implement different strategies for different files. And in our use case, all of the static assets are using the cache first strategy because we don't need this constant .js file to load every time from the network. It can load only whenever it changes, and it can be stored locally. Then we have our images are loaded from the network first. So we want to have the latest image, but if it's not available, we're okay with an older image. And then our latest deals, which is always network first. So it will always try to find the latest data from our network. So this shows how strong the service worker is, how resilient our app is when it goes offline, and we actually know the state that our app is in, and we have full control of how to act in different situations now. And we're fully leveraging our browser's API, our browser APIs, and our local storage APIs, which is either for data or for assets. Okay, and now the final part to make a website, to transform our website into a progressive web app. And the last part is to make it installable. It's to use the manifest.json file. So, as you already know, there are so many devices, so many browsers for these devices, and so many versions for the browsers and for the devices. And it's a small chaos out there. So whenever we want to generate the metadata for our web app, there are so many different resources and things we have to consider. For our web app, though, to be considered a progressive web app, our life is a bit easier as we can leverage some tools, and there is documentation for the metadata that we can use. So we do have the web app manifest in our disposal, which is basically this schema. And if we store this in a file called manifest.webmanifest or in a web manifest file, we can reference this in our web app, and our website will load all the metadata from this web app, from this schema. So there are a lot of generators out there that you can use to generate this manifest file. And I will cheat again, and I will, of course, load the final version of our app. So I'm going to load this version of our app. And as promised, we now have this manifest.json file. And this web manifest.json file has all the metadata that we need for our web app. And also, instead of adding a million metadata on our web app, you basically can reference this manifest.json file so it can load the appropriate metadata for your website. Yeah, an important part of this manifest.json file is the icons section. And to generate all the icons and the assets of your web app, you can use this tool called PWA Asset Generator. So if you run this command over here, npx PWA Asset Generator, and give it an SVG file, it will generate all of the assets that you need to generate to use in your app web manifest file. Okay, so we're gonna go over the impact that our app will have if we actually use this file and this metadata. Another trick is this library over here called PWA Compat. So you can use this cool library that also works as a very nice backfill. And whenever a browser doesn't support the manifest.json file, it will actually add all the appropriate meta tags that browser can use to have more information about your website. Okay, so the very interesting part of using this web manifest file is also that in Android devices specifically, if the following heuristics are met, if your user has visited the website twice, if it has a web manifest file, and it has a service worker, the user will actually see a banner when they visit the website that will say, hey, do you want to add this to your home screen? Because if the user is visiting this website often, the browser and Chrome specifically will make the assumption that this user actually wants this web app on their home screen. And if they actually click on this link over here, this will install the web app as we saw previously, like Twitter, and it will have a place on the user's home screen. So you can also do this by clicking Add to Home Screen on your web app. And once you add it to your home screen, it will appear on the mobile app's home screen. And once you tap on the app, on the web app, it will actually load it with a splash screen, and it will load it in a Chrome container. And it will look like any other app. So it will have its own logo. If you go to the battery, it'll have its own battery life. It is deeply integrated with the mobile ecosystem. And this is specifically for Android. Now, if we use the manifest file and all this metadata, this actually works well with iOS, where users can actually add the web app on their homepage as well. So they can do it like the following. They can add it on their home screen, and this is on an iOS device. They can then tap on the icon on their home screen and load the web app. And as you can see, the web app it doesn't have like a URL. It looks and acts like a native app and leverages that behavior. Also, on a Mac, on Mac OS, we can use Chrome to install our web app, and it will appear on our device like a native app as well. And of course, everything is wrapped in the Chrome container. And on Windows, we can pin our web app, and we can pin it to the taskbar. Or if we're using Edge or Chrome, and our web app has the criteria of a progressive web app, then it will actually show this install icon, and we can click on the install icon and it will install the web app as a native app as well. So as you can see, this manifest file over here, this manifest file doesn't only work as a way to universally set the metadata of our app, and if we use it in combination with libraries such as PWA compat to make this available in all the browsers, it can leverage each device's functionality and also integrate our web app as much as possible with the user's device's ecosystem. And that's what makes it installable and integrated. So the question is that all this is very cool. I have my website. The website has a service worker. The website has a web app manifest file. The website has the app shell. It's storing things locally and it's leveraging everything. How can I make sure that my web app has all the criteria needed for it to be a progressive web app? So if you open your Chrome browser, there is this tab over here called Lighthouse. So I've visited cardealspwa.com and I'm clicking on this Lighthouse tab over here, and we can click on Generate Report. So this Generate Report will actually load our web page, run a bunch of tests on it, and then it will generate a report. And not only concerning the PWA criteria, but it runs some tests on concerning your SEO, accessibility tests, and all that good stuff. For example, on the performance side, I could improve the performance of this app by implementing a couple of techniques that are mentioned over here. But I'm not interested on the performance right now that much as I am on the progressive web app side. So we went to Lighthouse, we ran the report, and it looks like we do have the criteria for this to be considered a progressive web app. It loads fast enough. It uses HTTPS. It has a splash screen. It has a service worker. And it has a web app manifest file. So these are basically the most important criteria for something to be considered a progressive web app. And also you saw all the improvements that a web app will have if it's considered a progressive web app. So it is installable, it can integrate well with your device, and it also works offline as well. And also there's this very interesting site called PWA Builder, where you can actually, whenever you have your web app running, for example, my web app is the cardealspwa.com. We can visit PWA Builder. You can add your URL. This is a web app, and this actually can generate native apps out of your progressive web app. So it will get the HTML, the JavaScript, and everything, and it will actually create all the files. If you want to upload it on a native on Android or on the App Store, this can generate the files necessary to do that easily. But if you don't want to do that, that's fine as well, as your users now will actually be able to visit your site offline, and also they can install the web app in your browser as well. Okay, yeah, it looks like this is the end of the presentation. And hopefully you found this very interesting, and we did meet the goals of this presentation, which was we had a clear definition of what's a progressive web app concerning the user experience side, concerning the technical spec side, and we did transform our simple web app into a progressive web app. And it passed all the reports, it had the offline functionality, and it also, we saw the experience that the user would have on every single device, be that Android and iOS or Windows or Mac. So if anybody has any questions, you can send them on the chat. And thank you for attending this session. Okay, it looks like there are no questions, and I would like to thank you all. This presentation is recorded and it will be offline as well.